Okay. So after the notation of big omega and theta, today we're going to see this topic here. So uh, asymptotic analysis of an algorithm refer. Let me increase the volume first. Okay. So refer to define the mathematical foundation framing of its runtime performance. So it's used to refer the mathematical foundation. Okay. So using this analysis, we very well conclude the best case, average case, and worst case scenario of an algorithm. Means asymptotic. With the help of this analysis, we can conclude the. We have already seen what best case, what is the best case, average case, and worst case scenario of an algorithm. Okay. So asymptotic analysis is input bound. That means if there is no input to the algorithm, it is concluded to work in constant time. If no algorithm is input, then it conclude work in a constant time. Other than the input, all other factors are considered constants. So this analysis refers to computing the running time of any operation in mathematical unit of computation. For example, the running time of an operation is computed as f of n, and maybe for another operation it is g of n square. This means that first operation running time will increase linearly with the increase in the n, and second operation will increase exponentially when increases. Similarly, the running time of both operations will be linearly the same if n is significantly small. So here, guidelines of finding out of time complexity of piece of code is there. First is loop. So the running time of loop is the running time of statement inside the loop multiplied by the number of iteration. So here execute n times. So n times for I in range zero and n. So here we have to print current number. Print current number, that is I. Okay. So here also it should be small I. That is this is the constant time. Okay. So therefore total time equal to a constant, that is constant is indicated by C. We have studied in my previous lecture, right? Then n is equal to Cn, sorry, equal to Cn equal to 0 of n. So this is type of loop. Then nested loop. So here analyze inside out. Total running time is the product of the size of all the loop. So this in nested loop, the total running time is the product of the size of all loops. So here outer loop execute n times. Okay, outer loop is execute n time. So I in range again, that is 0 n. Then for I in range, that is the inner loop execute n times. Okay. So inner loop execute in n times, and then we are using nested loop. So we got again that is for j. There's j in range, that is 0 and terminated by semicolon. So print I value percent %d and j value percent %d and ij value percent %d. That is a constant time. Okay, so this print the value of I with the help of print I value by percent %d and again j value by percent %d. Then this both value I j. This is a constant time. Therefore, total time is equal to C into N into total time is equal to C into N into N. So that is nothing but C N square equal to N square. So now this is the types of nested loops, then consecutive loops. And the time complexity of each statement. If then else statement. Worst case then if then else statement. If then else statement. So here worst case running time, the test plus either the end part or the else part. Okay, whichever is the large. So if n is equal to 0, yeah, 10, sorry, then print wrong value. Print wrong value constant time. Then print n else for I in range, that is n, need to complete this, that is n hash n time, then print current number I. Print current number I. Therefore, total time is C naught plus C1 into n, that is 0 of n या O of n. Okay, so this is about the guidelines of the what guidelines of finding out the time complexity of place to code. So now properties of notation. Properties of notation. So here transitive properties, reflexivity properties, symmetric properties, transpose properties is there. So here just properties, symbols and all given. So you have to just okay, just 1 minute. Okay, let's see first transitive properties. Transitive properties. So here this transitive property, like this is a properties, this is a transitive. So in this, if f of n, you have to remind this, remember that if f of n is equal to theta g of n, require the symbol theta g of n and g of, this is the properties of transitive g of n, so is equal to theta h of n, then f of n is equal to theta h of n, right? So here see f of n, g of n, g of n are getting cancelled and remaining is f of n is equal to theta h of n. Okay, so then if f of n is equal to, if this is only transitive properties, okay, if f of n is equal to of g of n and g of n is equal to of h of n, then again g of n, g of getting cancelled, and we remain, we have, that is f of n equal to of h of n. So nothing is this property में g of n getting cancel होता है और जो remaining part होता है वो we have to write. Okay, then again in this, if we have seen theta, मतलब notation को हम लोग देख रहे हैं यहाँ पे notation theta और then big omega theta, then omega we will see now. Okay, and this O is big O notation, right? So now it's, we are going to see the if f of n equal to omega g of n and g of n, then is equal to omega h of n, then f of n equal to this will be right in this. Okay, then f of n is equal to omega h of n. So this is about transitive properties. Here we are using to this property this is omega big O notation and theta is there, so just we combine f of n g of n, then we cancel the similar pattern and we take then non-similar, right? Like then f of n is equal to theta h of n, we cancel it g of n g of n, right? So this is about transitive properties. The next is a reflexive properties. Reflexivity. This is the second one. Okay, this is first. So let's see. So f of n, f of n f of n is equal to theta f of theta f of n. Then again like this, we have to put omega, just copy this, and 3 times we have to paste, 2 times I mean, I want to say that. So instead of theta we have to replace with omega and O notation. Okay, so this is about reflexive properties. Then third one, let's see. Symmetric. So here f of n is equal to theta g of n if and only if g of n, if and only if g of n is equal to theta f of n. Theta f of n. Okay, so this is about transitive properties, sorry, symmetric properties. So next one is transpose symmetry. Let's see this transpose. Okay, so The fourth one is transpose symmetry. Okay, so here f of n equals to Vigo notation, that is Vigo notation g of n if and only if and only if g of n, it is the theorem, you have to just understand this, and if and only if g of n is omega of f of n, then again write this, we will change which we want. Okay, copy the each, then paste here, then f of n is a 0, g of n if and only if the g of n is, instead of e we have to write again omega sign. Okay, so otherwise instead of this you can use this sign. Okay, okay, so some other properties of asymmetric notation is there. So these are the properties of notation which we have studied, that is omega notation. Just 1 minute. So this is about the properties of notation. And okay, so now performance characteristic of algorithm we will see now. The characteristics of algorithm of algo. Okay, if you want you can write this all algorithm. So first one is a space complexity. The first one is a space complexity. Okay, so performance analysis of an algorithm depends upon two factors, that is amount of memory used and amount of compute time consumed on any CPU. Formally, they are notified as complexity in term of. Then performance characteristics of algorithm, that is space complexity. Unless the space complexity, 2 points are there, that is the fixed component and variable components. In these fixed components, 2 components are there. First one is a fixed component and variable components. So in fixed component, space complexity, that is 1 minute. Okay, so in space complexity of an algorithm is the amount of memory. Okay, space, it is the amount of memory it need to run to complete completion. Okay, it is amount, space complexity is nothing but it's the amount of memory it need to run the to completion, that is from start to execution to its termination. means starting point to execution point to termination, that is space complexity. Space need by any algorithm is the sum of following components, that is fixed component. This is independent of characteristics of input and output. Fixed component is independent of characteristics, it is of input and output. This part include instruction space, space of simple variable, fixed size component variable, and constants variable. So the fixed component, which it is include the what fixed size component, variable, constants, and fixed size component, variables, and constants variable. Then variable component, this consists of space needed by component variable whose size is depend on particular problem. Okay, so in variable component, this size is depend on the particular problems. Okay, like input output being solved. The space needed by refer variables, and you can say stack space is one of the most prominent component. Okay, so therefore total space requirement of algorithm A can be provided as space is equal to fixed component plus variable component, means space is equal to space, that is of A, is equal to fixed component, fixed component, fixed components of A plus variable components of A. Variable components, variable component of A. Okay, what the fixed now with space complexity of an algorithm is the amount of memory it needed to run of to completion, that is from start. मतलब space complexity ये क्या करती है, अमाउंट ऑफ मेमोरी रिक्वायर होती है इसमें कंप्लीशन करने के लिए, मतलब needed to run to completion, जैसे कि starting, execution and terminate. So space need by algorithm is the sum of following components like fixed components and variable components. So here in fixed component, this is the independent of characteristic of an input and output. So this part includes instruction space, space of simple variable, fixed size component variable, and constants variable. And in variable components, this consists of space needed by component variable whose size is independent on the particular problem, instance, input, output. Now, determine the variable which are initial by some default value. Okay, then time complexity is there. Third character is the time characteristic complexity. Sorry, time. This is the second one. In the first one is the space. What first one is space complexity. Under these two components, they are fixed and variable. And then time complexity. So time complexity of an algorithm, basically when convert to program, is the amount of computer time it needed to run to completion. The time taken by program is sum of compiler time and run execution time. Okay, the time taken by program is a sum of compile time and execution time. The compile time is independent of instance, that is problem specific characteristic. Following factors affected time complexity, that is characteristic of compiler used to compile the program, computer machine on which the program is executed and physically clock, then multi-user execution system, number of program steps. So time, therefore, the again time complexity consists of two components, that is fixed and variable. So for any algorithm, A is provided as time of A equal to again fixed time of A plus instance time of A. Here the number of steps is the most prominent instance characteristic, and the number of steps any program statement is assigned depends on the kind of statement, like comments count as 0 step. Okay, therefore to calculate total number of program step, we as use following procedure, like example, like statement we require steps per execution, we require frequency, and total steps we require. So today's lecture is over here. Thank you.
Any problem? Hello, Abdullah, Bhushan, Faizan, Prasad, Rutuja, Saurabh. Any problem? Hmm? Okay.
No
No, ma'am.
problem.
Shall I end? End करू?
हो.
हाँ, okay, करा.
Yes, yes.